In this video, we continue modeling our steel hull by creating the first two-dimensional frame. Let's start immediately and insert the top node of the dual pitch roof. We click on the new node icon and enter the desired coordinates, and then confirm the entry, which we can do by hitting enter. Now we can right-click to cancel out of that tool. Next, we want to create the left roof beam with the taper on the left at the member start. To do this, we click on the new single member button. Now we're going to come across one of the new innovations of RFEM 6. In defining the member properties, it is also possible to create a taper or an offset at one or both ends at the same time. So let's go to the section tab. And then under distribution type, we're going to select the option tapered at start of member. And now we can also enter in the length of the taper in feet or as a percentage. Below, we also change the alignment by selecting the top option. In the section with material area, we will now define the respective sections for the member start and the rest of the member. We click on the Import from Section Library icon, and in the new dialog box, we click on Parametric Eye Sections to become familiar with the parametric sections. In the new window, you can find the already created sections in the list on the left, such as the W14 by 38, which is our columns. The second entry in the list has been created automatically by RFEM as a placeholder. We will now adjust it to our specifications under the Parametric Thin Walled tab. Here we can either enter the desired parameters of the geometry manually or import them from an existing standardized section. So let's click on the Import Parameters from Standardized Section icon. And look for a W shape, 16 by 36. We confirm the entry by clicking OK. Now the geometry of the standardized section has been adopted, and we can change it as desired. When we are finished with the taper's geometry, we can copy this section in the list on the left using the respective symbol to define the section for the rest of the members. For the copied section, we want to adjust the height accordingly and confirm the entry by clicking OK. Thus, we have defined the two new sections that we have to assign to the member start and the member end. The bitmap on the right of the window shows the entire member. We confirm the created roof beam by clicking OK. And inserting it by first clicking on the column end and then the previously created node. The order is very important because the taper is defined at the member start. We exit the input by right-clicking, and since we are modeling a 3D hull, it must be sufficiently stiffened to be able to insert bracings and purlins more efficiently. So during this tutorial series, we will add internal nodes to the two members. We have several options for this. We can decide to simply divide the members into intermediate nodes by right-clicking. We activate the Node on Member option so that nodes are created on the members without dividing them. Now we would like to complete the 2D frame. To do this, we do not have to go through all the steps again, and we can just mirror half of the frame to the other side. So first we select the entire model and click on the mirror icon at the top. In the new dialog box, we activate the Create Copy option so that half of the frame is copied. In the mirroring parameters area, we leave the coordinate system at the default setting and select the desired mirroring plane. Afterwards, we have to enter the coordinates of the mirroring point, or click on the point on the structural model using the respective symbol. We click OK to perform the mirroring. Now we also need to reverse the top right roof beam so the orientation is correct. We can do this by right-clicking on the beam and clicking Reverse/Member Orientation. The first 2D frame has now been inserted, and in the next video we will continue the modeling. Till next time.